Hi everyone, thanks for joining. I'm Kashyap and we are from Credit Karma. We are very excited to take you through our journey of building a self-service microservices CI, why we are using GitHub, and how it has helped us scale and rapidly deliver products for our members. But before I start with the journey, let me take a brief moment to give a plug for my employer, Credit Karma. Credit Karma's mission is to make financial progress possible for everyone. And we know that thinking about financing can be frustrating at times. And that's why we are working hard to make the process simpler and easier for more than 75 million members. I lead engineering efficiency team at Credit Karma, and my team's primary focus is to improve developer experience through test, production, and development lifecycle.
Hi everyone, I'm Amit Mishra. I'm a senior build and release engineer at Credit Karma. I've been with the company for almost 3 years now, and I'm also part of the integration efficiency team.
And I'm Daniel Martinez. I'm also a software engineer in the platform integration team, and I've been part of Credit Karma for the past 5 years.
So in the next 40 minutes, we will take you to the journey into our universe on how we evolved our CI ecosystem. This slide pretty much gives the agenda. We'll briefly touch over our history on how we started and what we are today. And then we'll go over the services part, like how self-service has improved and empowered our CI systems at Credit Karma. And then we'll touch base over what is GitHub, why did we choose GitHub route, and how is it making a big impact on the way we develop our CI ecosystem. Then Kashyap is going to go over the Docker pipeline it's going to showcase how security is embedded into our Docker pipeline and how we are actually pushing services from co-op into production using this Docker pipeline. And after that, we'll touch base on the future part on what's our future look like. So pretty much, this is our agenda. And are you guys ready to see our universe? Let's do it.
So before we start, let me tell you a little bit of our history. But for that, we need to go back to the beginning, back to when Credit Karma was just a cloud of gas. Back then, it wasn't known if we will take form into anything or if we will just float into space. Luckily, Credit Karma became a beautiful galaxy and also a very successful company. But of course, as we grew, our mono became a black hole. No one really knew what happened in its center. We just knew that it was there. So as time passed, we knew that it was time to start decomposing mono, and the first microservices appear. Back then, we had a single CI instance that had a lot of limitations, and that was getting out of control. Partially because Amit will break it all the time, but mainly because we kept adding many jobs, and eventually we needed to give access to everyone because they needed to be able to manage their dependencies. And you guys know what happens when everyone has access to critical systems. Things will break. As you guys know, CI, everything revolves around CI. So we took a look at the newly created microservices, the PHP services, Scala, TypeScripts, and we noticed that there was a pattern. The release pipeline was almost the same. So we knew that we could make CI configuration and setup easier and faster, and we could help those teams be more self-service, and we could empower them through CI. So that was a little of our history. Now let's talk about self-service. As you guys know, we humans don't like to wait. We want everything to be done right away. So for that reason, I created what we call the CI Builder. And what the CI Builder is a Jenkins instance integrated with some tools like Terraform, Docker, AWS, Artifactory. And the CI Builder enables teams to easily create the already configure and set up CI instance for their service. So like I mentioned, so now let's take a look at the CI Builder. And like I mentioned, the CI Builder is a Jenkins instance that creates other Jenkins instances. This process is also known as Jenkins inception. And the Jenkins builder, the CI builder has two main jobs: create new Jenkins and update Jenkins container. But today I'll focus on the first job, and I'll show you how we are creating CIs, fully configured CIs for our service teams at Credit Karma. So when a service is ready to start testing their code and building artifacts that they will eventually push to production, they come here to the CI builder and they provide some information to us. The first thing that we need to know is the team name. Because we have, at Credit Karma, we have subnets for every team. So we need to know where are we going to be deploying that infrastructure to. The next very important item is the Docker image. Like I mentioned before, we already know how our Scala services and PHP and TypeScript services look like and what they need. So we created some templates for them that are ready to be used. But also, we have some other teams at Credit Karma that like to highly customize their Jenkins. And for that reason, we allow them to provide their Jenkins image to us, and we deploy that for them. The next item is the service repo. We need to know where the code is so that we can inject that into the template that we are providing to them, and so that when we spin up the CI instance for them, we can start cloning and pulling and pushing their code to GitHub without the developer worrying about it. And the last item, which is really important, is the instance type. The user has access to modify the instance type. Like I mentioned, some of them have really complex Jenkins instances, so they might need an instance with a lot of power, but other teams might only have a couple of jobs that they only run a couple of times per day. So they might need a smaller instance, and for that reason, we allow them to specify the instance type based on their needs. After they provide that information, they simply click build, and then we execute 4 stages. On the first stage, we have some Ruby scripts that we use to generate the necessary Terraform files and the necessary setup scripts to deploy their infrastructure. On the second stage, we use Terraform to deploy the infrastructure with the scripts that we created, and we run the setup scripts to provision that instance, and we start a few containers. Of course, one of them is Jenkins container, and we also start a Splunk container for logging and some other containers. After we successfully deploy the new infrastructure, we send the user all the necessary information for the new infrastructure on an email. And lastly, on the last step, we add a DNS record so that the user can easily access their Jenkins instance through the browser, and they can integrate that into any of their tools. So now let's look at the benefits. Before, if you remember, we had a single CI instance that was getting out of control, and that everyone kept asking us for help. And that wasn't scalable. Now this process is more scalable. As we grow, we can create more Jenkins instances for the teams. Rolling out and rolling back is extremely simple. They just have to click a button. Implementing it, again, the user just has to click a button. They don't need to know anything about AWS, Artifactory, Terraform, not even Jenkins, because we fully configure the pipeline, and Kashyap will talk more about that later. And what is very important, they have full access to their Jenkins instance. They don't have to ask Amit for help anymore. They fully own it. They can do whatever they want.
So clearly, CI Builder has been a game changer for us when it comes to any new engineering team which joins Credit Karma and needs a new CI. With one click of a button, they have their CI, which is up and running, and it's fully configurable with our Docker pipeline. So now, since you know what our history was, how we started, what is self-service CI means to us, let's move on to the next phase, which is why GitHub? Why did we go the GitHub route? So to answer this question, it's very important to know first what was before GitHub. Before GitHub, we had an in-house version control system that was not scalable. It was running on a lot of custom plugins, And you know what happens when you have a lot of custom third-party plugins. Upgrades can be nightmares. We ran into like days and days of upgrade issues, downtimes, and it was not very intuitive and not very collaborative. So GitHub, of course, came as the obvious solution for us. GitHub comes in both SaaS and enterprise flavors, depending on what your needs are, how you want to host it. You want to host it behind your firewall, enterprise is the way to go. If you don't want to worry about the underlying infrastructure, SaaS is the best friend. It's an industry standard used over millions and millions of users all over the world. GitHub has now become the standard way to collaborate the code. Marketplace comes with amazing integrations. Tooling around those integrations can basically help to empower your workflow where you can add these integrations and it can actually make your CI or other workflows much, much more empowered. And REST APIs, of course, the biggest advantages where you can have REST calls done and make tooling around REST calls, again, to help your CI workflow to be more effective. So this basically goes over why GitHub. Now, how have we used GitHub to do some of the status checks that we do on our code base? So let us list some of the status checks that we run when you, as a developer, open a pull request at Credit Karma. So number one thing is the approvers, and I'm sure most of you guys are very familiar with this. There are minimum number of approvers that we have in order for pull request to be approved. You can set this count to whatever you want, whatever your needs are. It's highly customizable. There are some underlying tests that we run in the background whenever a pull request is created. These tests are integration test, unit test. And I'm going to show that in next slide where a screenshot of these tests, how they're executed and how the results are returned back to the pull request, and which makes sure that every pull request, any pull request does not break the test suites that we have in place. Commit messages. This another check we have in place to make sure that you don't have funny commit messages for the stories you're working on. For example, my friend Daniel, he loves to have awesome commit messages like Daniel's best fix or best fix in the world. Well, we don't promote those commit messages because we want to make sure that when we do a production release, we take these commit messages and we create release notes out of it. And those release notes are should be very meaningful to state a fact that what went out in a release, what were the bugs, what were the enhancements. So our commit messages have to have a mandatory active Jira ticket in that. And we could customize that commit message to whatever regular expression we want it to be. And the next one is the owner's check. GitHub just came out with this feature, but when we migrated over, we had to implement it right away. It's a pretty new feature, but we had to invent owner's check before GitHub came out with this. It's basically making sure that if you're working on a story in which you have to touch a file or work on a file which you might not be an expert, like a SQL file, and you want a third eye on that, maybe the DBA is looking at it, that's when owner's check is very, very effective. That's pretty much making sure that if you're not an SME on a particular domain and you have to work on a story where you're touching that particular file, we will automatically add those SMEs as part of the approvers in your pull request. So these were some of the status checks that we have in place. The next slide is how do we implement those status checks? Like, how does it all happen? So it basically happens to our CI ecosystem, which is part of webhooks on every repo. So whenever you create a pull request, the webhooks on that particular repo gets triggered. And the underline, it actually triggers the Jenkins jobs in the background, which run all these checks. So let us look at a screenshot of a sample pull request at Credit Karma. And it actually shows you all the checks that I've talked previously. It is going over approval count, and then some of the unit tests that we run. There are a couple of them which are running in parallel, making sure that you have not broken the test suite. And we are very particular about that stuff. Golden Gate is our homegrown utility where we don't allow end users to merge code into the main code line. Actually, there is another build that runs, making sure that it merges a master into feature branch, making sure there's no race condition, and we run the test again. And that system user actually merges your code into the master code line. And then owner's check is something that I talked in the previous file. So probably this PR had some of the files where the author wanted some of the files to be peer reviewed by an SME. So next thing that we developed using the REST calls and hooks part was the bots. So what was happening before bots? Our team was getting flooded with requests from our engineering team saying, hey guys, can you make us a repo? Or can you rename us a repo? Or how do I list some repos which are owned by a particular engineering team? So these were all very manual and day-to-day repetitive tasks. And we wanted to focus more on developing tools rather than fulfilling these day-to-day manual activities, which are pretty repetitive. So we started developing our chatbots, which are actually helping us to achieve a lot of these features. So here is a human interaction with one of our chatbots, and it actually tells you what our chatbot is capable of doing. It can create you a repo. It can give you, like, it can initialize some of the hooks to your repos. You can search repos using just this chatbot and a bunch of other stuff. So as you can see, our chatbots are very handy when it comes to doing repetitive tasks for our engineering needs on a day-to-day basis. So let's go over some of the benefits that we achieved when we have configured the hooks and the bots. So let's look at some of the benefits of hooks first. Hooks, as you see, we have a bunch of tests that we run, and we are making sure at every point of time we are delivering clean code into our main code line, which is making sure clean code is going out in production and we have minimal bugs. The next thing is approvals. We are making sure that you have adequate number of approvals before your code is being merged into the main code line. Specific approval is a direct reflection of the owner's check that I discussed previously, making sure that if you're not an SME on something, we are adding those people as your approvers, and you are confident enough saying, all right, I'm sure this stuff is not going to break production. And automated merging is the golden gate part that I discussed earlier. No humans are allowed to merge code directly into master code line. We have automated processes which actually merge this code into the main code line. Now let's talk about some of the benefits of the bots. Security. Whatever we do at Credit Karma, security is our #1 priority. So to create repos or do other tasks with stuff, bots make sure that it comes in built. So it's a way when a bot creates a repo, we are pretty much sure that it's creating it with all the security protocols that we have programmed it to do it. Retrieving information from a bot is just chatting in a Slack, basically chatting with the bot. You don't have to go to GitHub UI or somebody is new to UI. He or she can actually list those repos by just chatting onto Slack messages and getting the information. And it pretty much allows us to standardize the way we create our repos, the way we name our repos, so that it's very easy to search for repos under your org name. If the repos are named in a very funny name, it kind of becomes tough to go over what repo is where, which repo makes what sense. So bots typically helps us to achieve all this stuff. And last but not the least, bots are always available. They don't take PTOs. They don't fall sick. We three are presenting here, and our bots are doing stuff at Credit Karma.
So next up is, I'm going to review what Docker pipeline is. But before that, it's important to find out what is a Docker pipeline and why we needed to build it. How many of you have either built or worked on a monolith? Wow, I was expecting many more hands. I guess I'm getting older. Let me ask the same question differently. How many of you have decomposed a monolith into composable microservices? OK, I guess we are in the same boat. Migrating from monolith to a microservice is not easy. And we have embarked on this journey about a year and a half ago. It's not easy because there are a lot of advantages using mono. And we have benefited from it quite a bit. Things like atomicity with releases, deployments, rollbacks, code refactors, and reuse. All of this is done within a single branch. All developers work on a single branch. It's very attractive, very useful. But there are also many disadvantages using monolith. And we have been hurting quite a bit with the pace of development using monolith. So in order to break away from monolith into microservices, we started looking into building microservices and started looking into running Docker in production. And we knew that we had to build these Docker containers securely and reliably without impacting developer productivity and agility, and making sure that a Docker container that's running in production can be traceable back to a commit in GitHub. So in order to meet some of these requirements, we decided to build a two-stage Docker pipeline. Docker pipeline that will securely build images and publish them in production. Let's look at how the Docker pipeline works. So the pipeline works in a locked, centralized Jenkins environment. This locked environment is triggered by a remote CI instance. This is a team CI instance that Daniel just reviewed. This instance has a pre-configured jobs to remotely trigger both stages of this pipeline. And the first stage of the pipeline is building a bronze image. And it typically starts with cloning GitHub repo for a service or a tag for a service. Once the repo is cloned on the central environment, we do a static scan and code analysis on this. If the static scan is successful, we trigger a Docker build, and the Docker image is produced using this build. And then that image gets statically scanned on the central environment. And if the scanning is successful, we publish this Docker artifact into a private registry inside our corp environment. And we call it bronze registry. So at this point, we have an image that went through some of the security validations, but we haven't done any additional validations on this. So we pass this image back to the team CI to run additional integration tests. And when the tests are successful, we are ready to kick off the second stage of the Docker pipeline. And the second stage also runs on a central Jenkins environment, and we call it gold stage. All we do here is we promote the bronze image to a gold image within the same Artifactory repo that we use. These gold images then gets replicated into production environment, and at this point, developers are ready to push their actual application that they build into production. So far we have been talking about CI, GitHub, how to build Docker images, mostly CI-centric world, but it takes a lot to build a microservice. Typically, a developer will first think about what kind of frameworks or libraries he or she is going to use. How is the application they are building is going to be monitored in production, and how is going to be deployed in production, whether they need a single instance, they need a cluster of instances working together based on the load characteristics of the application. So we thought of building an end-to-end pipeline that would create a service and make it production ready. And we call this the service provisioning pipeline. So we started here with the Docker pipeline, and when we started stitching together the service provisioning pipeline, we ended up here. And let's take a look at briefly how this pipeline works. It starts with creating a service repo for a service that a developer is building. And then we inject the working skeleton, a working code, whether it's a framework related to Scala or Java or PHP. We inject the working skeleton code into the repo, and then we spin up a CI for this service using the CI builder. And then we attach this CI with the repo using a series of webhooks that will introduce the status checks on PRs and commits. And then finally, we build an Artifactory repo so that the service can be published into Artifactory, and then attach deployment configurations to the service. So at this point, a developer or a team can actually create a service and get it ready to run through the Docker pipeline, and then finally publish this into production environment. This entire cycle used to take weeks because it was all manual, but with the service provisioning pipeline that is fully automated, it takes hours. So a developer could be working on a concept in the morning, run through this pipeline in the afternoon, and actually prototype and deploy the application in production for our members to use same day in the evening. This is an example workflow. We use Airflow to wire up all the service provisioning pipeline and some of the tools that we use, Terraform. Of course, the infrastructure is deployed in AWS, and because we are building Docker, we have Dockerized the entire pipeline as well. So we are eating our own dog food. And Jenkins is the backend engine that we use to actually execute the workflow. So let's look at some of the benefits of using an automated service provisioning and Docker pipeline. Because this is fully self-service, developers can build and deploy their services without any bottlenecks. With a central Jenkins environment that is running security scans, it's very flexible. We can add new scans when they are available without impacting developer productivity. And then because all the services are built from a same tool, we get standardization for free. And then because we tag Docker images using Git SHA and SAMR version of the services, an SRE looking at a Docker container running in production, debugging the container, can actually trace back to the GitHub code from which the container was built.
So now that you know about some of our GitHub integrations and you know more about our Docker pipeline, you can see how we have evolved and how big and complex our universe is. So now we are going to share some stats with you. If you remember, we started with a single CI instance that had a lot of limitations, and I don't know if I mentioned, but someone will break it all the time. And now we have over 150 Jenkins instances fully owned by our service teams. They don't have to come to Amit for help anymore. All these Jenkins instances are producing over 5,000 builds every day. But some of these builds are running actually tests, unit tests, integration tests, performance tests, many other tests. And they are also creating some artifacts. And Amit will tell you more about that. And thanks to the integrations that Amit mentioned, we are producing over 15,000 calls to and from GitHub on a regular day. And lastly, we are producing over 200 Docker images. But like Kasha mentioned, not all those images make it to production. Some of those images are testing images, bronze images, and a very few of them gold images that eventually will make it to production, and the service teams will deploy their service.
So we talked about our CI instances, over 150 of them running 5,000 builds a day. What happens when they output some artifacts? If we go back in time, we were all working on one mono, and we had a staging server that would host our artifacts that had to be deployed. But as we grow, we knew that we needed a very, very solid repo management system in place, and Artifactory to us is our choice, because it actually serves our repository management for our Yum repos, for our Docker registry, and all the different artifacts like NPM and all that other stuff that gets deployed in production. So when it comes to Artifactory instances, we have multiple Artifactory instances which we have implemented in our corp and production networks. And again, I'm going to stress out on the security factor here, because security is on the prime of what we do at Credit Karma. We make sure there are certain security rules which actually dictate the terms on how artifacts are being propagated from co-op into production so that they can be deployed. Not all the artifacts have to be in production because they did not pass a test, or the security replication scheme just kicked them out, saying you guys are not safe to be deployed to prod. So Artifactory replication and security plays a major role when it comes to replicating our artifacts from co-op into our prod network. We have over 250 repos in today, where there are different types of repos. These repos are assigned to different teams. In contrast to what we were 2-3 years back when we were just working on mono, now we've developed and we've matured so much that we needed different types of repos like NPM or Docker and other Yum and all those repos. So we're proudly hosting more than 250 repos for our different engineering teams. At this point of time, all our Artifactory instances are hosting more than 500,000 artifacts. And as we are talking here, this number is going to increase because all our CI instances are pumping out those artifacts and just pushing out to Artifactory, so it never stops. So we talked about our CI instances, we talked about the artifacts. Now, who consumes them? Of course, our services team. Our services teams are basically consuming all these artifacts. We were at a point where we were just having one mono app and the whole engineering was working on them. And today we are proudly supporting 40 different services team, which are actually working on different microservices. They're interacting with more than 1,000 repos in GitHub as compared to just one repo when they were working on mono. And this is the most cool part that I like about it is that it's all self-service. All the teams from day one are self-service, be it configuring the CI or configuring the hooks to throughout the part of the software development life cycles. None of us or our team are a bottleneck to our engineering service teams.
So every project gets this during its life cycle, and we are not an exception. I'm going to go over some of the challenges that we faced. We started back when Docker wasn't stable. Kernel panics were a real thing. Escalation privileges were a real thing. Fortunately, Docker is much stable now. And as you add self-service tools, you have to make sure that you are able to scale it. When we started building our tools, there were very few teams who were using these tools. But as Daniel mentioned, we have over 150 Jenkins instances that are constantly running builds, 5K builds per day. We have to make sure these instances are always backed up. We have to make sure that they are running with latest plugins and that they are compatible, that they are running with appropriate security patches on each of these instances. Next, I'm going to take a look at what looks like in our future, what additional things we are working on in our future. So we are looking into config-based CI, CI where developers produce the code or the framework on which they want to run the CI, and the actual jobs are running in a central environment. Tools like Circle CI, tools like a Jenkins file come to mind, and we are prototyping some of these, and we are hoping that we can come next year and present how this config-based CI is working for us. I feel like this is where GitHub shines. New integrations are always coming along. Things like branch protections, owners files, and we are constantly looking at new features and integrating them into our development workflows. Additionally, GitHub has a really nice marketplace where third-party tools provide an easy integration, whether it's through GraphQL or RESTful APIs. We want to extend the reach of bots. Bots are currently providing a lot of self-service. Someday we want to create an entire service and deploy it in production using bots, of course, minus the feature or code development. And then we want to make sure our tools are portable to any clouds. Right now we are using AWS, but because the underlying tools that we use, Terraform, Docker, they're not, they're cloud agnostic. So hopefully that provides us opportunity to migrate to multiple other clouds in future.
So before we wrap up, we want to cover one last point, which is our takeaways. And that's going to complete our constellation here as well. So what were our big takeaways when we were developing this whole ecosystem? And we wanted to share some of our learnings with you guys. So it's very important for when you're developing a system like this, a smart or a complicated system like this, the first question you need to answer is, what's your problem? Like, what problem are you trying to solve? Do not create solutions just because XYZ company implemented some cool tools. Oh, we're going to implement that same solution. No. Identify the problems which are critical to your business and then find a solution which will make more sense in your domain or your business. So that's one thing that was one of our biggest takeaways. Self-service should be the key to develop any service, especially in an environment when you know it's going to scale up very high. If you are working on any solution which is not going to scale up, and it has to scale up, and it's not self-service oriented, it'll be a problem. It'll become a big problem in future. So all our services, all our tools that we have developed are self-service centric based. continuous integration should be at the heart of everything you guys do because it helps you to identify and iterate over issues at the very early stages of the software development lifecycle. And the sooner you catch them, the cheaper it is to fix them. The later you catch them, it becomes a bigger issue and it's much more expensive with engineering hours involved in fixing those issues. And evolve step by step. Do not plan to implement the whole solution in 10 days. Of course, it's not going to work out. Whatever we develop, maybe you guys might need 25% of what it is, or you might need 200% of what we develop. But make sure to evolve in steps. Universe also took billions of years to evolve. So make sure you develop in small steps, take feedback from your customers, which is your engineering teams, and then based on those feedback, add more features and evolve in a step-by-step approach. So that pretty much wraps up our talk. And you can look into our blog site, engineering.creditkarma.com. That's the Twitter handle for our engineering Twitter, which is Credit Karma Eng. And on the right side, these are all three of us. You can contact us directly on Twitter. And thank you so much for taking time and coming to listening to our talk. Thanks again.